My name is Tim Hudson and I'm a mechatronic engineering and computer science student at the University of Sydney. In collaboration with the Intelligent Transport Systems Group at the Australian Centre for Field Robotics, the aim of my project is to classify pedestrian interactions with autonomous vehicles.
As autonomous vehicles transition toward mainstream use, a major obstacle is the complex behaviour that pedestrians are capable of. This is especially the case in shared spaces such as USyd's Eastern Avenue. Whilst autonomous vehicles are able to use their various senses to avoid running into pedestrians, they are not able to understand their behaviour. A lack of contextual information, such as whether a person has noticed the vehicle or if they are distracted by their phone, may lead to inefficient and potentially unsafe interactions. For my solution, I've developed a system that encompasses multiple open source software modules to process camera data. Firstly, the playback module extracts a video frame and publishes it to each module. YOLO takes an image file and produces bounding boxes around the pedestrians with an associated confidence level. These bounding boxes are then passed to deep sort, which tracks the bounding boxes over time with an associated ID. OpenPose uses deep learning to estimate the body pose key points of people. OpenHeadPose then uses this pose data to estimate the head orientation and gaze direction of a pedestrian. The pedestrian tracker synchronizes and processes all of this data, then overlays it onto the output video. By tracking the body pose, head orientation, and gaze direction of a pedestrian over time, this information can be used to inform the decision-making process of an autonomous vehicle. A simple color system is used to classify specific actions of a pedestrian. Red indicates a pedestrian that has not seen the vehicle. Green indicates a pedestrian currently looking at the vehicle. Blue indicates a pedestrian that has seen the vehicle but is not currently looking. And orange indicates a pedestrian that is distracted by their phone. The accuracy of this system is heavily dependent on the image resolution and processing power of the computer running it. However, it shows promising results with classifying pedestrian behavior. Although the final system doesn't operate in real time, it may prove useful for offline analysis of footage and automatic annotation of datasets. Through this project, I've learned a lot about software development and deep learning techniques. In particular, I've learned that predicting pedestrian behavior is an incredibly complex problem. Ultimately, it's important to ensure that autonomous vehicles are given as much useful information as possible so that they can act in a safe and efficient manner.